The moving of soil. When a river builds a delta, it uses borrowed materials for the job. The soil of a delta comes from hills and farms along the way. It is washed into the river by rainwater and carried on downstream and dropped at the river's mouth. This moving of soil by water is called erosion. Wherever water flows over land, erosion is taking place. Every river in the world carries soil that was washed into it by flowing rainwater. How much it carries depends on the heaviness of the rainfall and the condition of the soil itself. Soil erosion. When the rain falls on soil that is thickly covered with growing plants, very little erosion takes place. The plants break the shock of the falling raindrops so that the water strikes the soil gently. The plant roots soak in the water, hold the soil in place, and help to keep it from being washed away. On plant-covered land, erosion is a slow process. The soil moves very slowly into the river. The water is clear. Fast erosion. But in places where whole forests are cut down or where farmland is plowed and left bare, the soil's protection is gone. When it rains on bare land, a huge amount of soil is washed into brooks and rivers and is carried down to the sea. In such places where there is no plant protection for the soil, erosion is speeded up greatly. This rapid erosion is a loss to everyone. How erosion affects us. Erosion is a loss to the farmer because it takes away the topsoil, the best part of the soil for growing crops. Underneath the topsoil is a poorer soil that gives poorer crops, smaller plants that bear fewer and smaller fruits and vegetables for feeding us. Erosion is a danger to the people who live in farms and cities near a river. As the river bottom becomes heaped up with sand and soil, there is less room for the water to flow through the riverbed. Then, in times of heavy rains and spring thaws, the river may overflow its banks and flood the surrounding farms and cities. People are made homeless. The water supply becomes polluted by sewage and mud that washes into reservoirs and wells. The impure drinking water, the cold and the damp and the crowding all spread disease. To protect themselves against floods, people have to build high river walls called levees out of concrete or out of heaped up bags of sand. But heavy rains bring more mud and more floods. As long as rapid erosion continues, more soil is washed into the river, and the danger of flood remains. Erosion is a loss to all of us, not only to the farmer, but also to people who live in cities. When topsoil is washed into rivers and carried out to the sea, its usefulness to us is gone. There is that much less good farmland to feed us and to provide us with cotton and other useful crops. With less and less farmland, we have to pay higher and higher prices for what the remaining farms can produce. What can we do about erosion? How can rapid erosion be stopped? It is not a simple matter that can be settled overnight. It takes a long time and requires the help of every farmer and lumberman, of everyone who works with the soil. The job is directed by a special agency of government called the Soil Conservation Service. They help us save the soil in two main ways, by protecting the soil and by controlling the flow of waters. To protect the soil, it must be covered. Where forests have been cut down and where land has been left bare, the soil is covered by planting young trees or other green growing things that hold the soil and sponge up water. We also have to keep the rainwater from flowing rapidly over steep and hilly land. Fast-moving water carries off a great deal of sand and soil, but water can be slowed down in several ways. Hilly land can be plowed so that the furrows will run level with the hill instead of running downhill. Conservation workers help the farmers plan their plowing so that the rainwater stays in these level furrows and soaks into the ground instead of rushing downhill and washing soil away. How dams help. Another way to keep water from carrying land away with it is to build dams to hold back fast-flowing rivers. These dams keep the water from rushing wildly along steep places with every rainstorm and hold the water back so that it can be let out a little at a time throughout the whole year. Not only do dams protect the countryside from flood and erosion along riverbanks, but they can also supply water to farmers through the dry season. In some places, water from a dam is used to turn the water wheels of electric generators. The force of the flowing water makes useful electric power instead of destructive floods. Dams have other uses besides helping to control floods. In many places, a river builds up in the valley behind a dam and forms a lake which can be used for swimming, boating, and fishing. The water from such lakes often is also used to turn electric generators which make electricity from the surrounding area. In this way, fast-moving water can be controlled and released a little at a time to do useful work instead of bringing destructive floods. By controlling the swift flow of water and by keeping the soil covered with growing things, rapid erosion of the soil can be prevented. Streams and rivers can flow peacefully and usefully through the countryside on their way to the sea. Underground water to the sea. It's always raining somewhere. At this moment, several thousand rainstorms are raining down on the world. Millions of gallons of water are striking the Earth's surface. Every second, about 16 million gallons of clean, fresh rain pour out of the clouds. Some of the water flows and swirls and cuts its way down mountain brooks and rivers that speed to the sea. But not all the land in the world is in the shape of mountains. The rain also beats on the level lands and lowlands. Some of it soaks into the soft soil and seeps into the sand. What happens to this water? Where does it go? Water under the ground. The rainwater that soaks into the ground goes on a long, strange journey through the dark, secret places of the earth before it reaches the sea. This water goes down into the earth to become part of a vast underground water system that is like a flowing, wavy lining under the earth's outer coat. To explore this moving, changing layer of water underground, you would need all kinds of digging machinery and perhaps a diving suit. It'll be easier to see what we can find out by doing some experiments. Begin with this experiment and save the setup for more exploration later in this chapter. Experiment. You will need a large jar or glass baking dish. A fishbowl or aquarium will do even better. You'll also need enough sand or gravel to fill the jar, and a pitcher full of water. Do this. Fill the jar with sand or gravel, and then slowly pour water on top. Look through the side of the jar and watch the water sink down to the bottom. Keep pouring water until the level of the water is about 2 inches below the top of the sand. Now, let's think about what has happened so far. We found that the water seeped down through the sand easily enough. It stopped seeping down when it reached the glass bottom. We say that sand is porous. That is, there are little spaces or pores between the grains of sand, and the water works its way down through these pores. The water did not seep through the glass because glass is non-porous. The water table. Rainwater falling on the earth soaks down through the soil and even through some kinds of rock that are porous. It seeps down until it reaches rock that is non-porous, like the glass at the bottom of the jar. Here the water stops going down. Then, as more rainwater keeps seeping down through the porous layers, it piles up on top of the water already there, on the rocks that are not porous. As more water comes in, the level of this underground water rises, just as it did in the jar of sand. This water level under the earth is called the water table. Where is the water table? Almost everywhere in the world there is water under the ground. If you dig down deep enough, sooner or later you will reach the water table. In some places, it is quite close to the top. In some places, you would have to dig several hundred feet through soil and porous rock. In some places, you would have to dig through soil and drill through non-porous rock to reach the water. Even builders can't always be sure where the water level is. Sometimes, when the cellar for a new house is being dug, the diggers suddenly reach the water table even though the rest of the houses on the street have been dry. Where the water table has made a sudden upturn underground, the cellar hole turns into an unwelcome swimming pool that has to be pumped dry and the sides and bottom made waterproof. Using the water table. All over the world, people have found ways of making use of the water table for a steady supply of water. You can find out how by going on with the experiment with the jar, sand, and water. Experiment. Now you will also need a spoon and a tin can with the top and bottom removed. Do this. Hold the can upright and then wiggle it down through the sand, as if you were boring a hole. Work the can down until the top is even with the sand. Now use the spoon to scoop out all the sand in the can. You will find that as you dig out the sand, water will come up in its place. When all the sand is out, the can will be filled with water up to the level of the water table in the jar. What you have just done is to dig a miniature well.